Yeah, welcome to Brainiac Survival College class. And the question that we have here is from particular solution. We have to find a particular solution at point 2, 1 if x dy plus 2y dx is equal to 0. So now here we have the differential equation. The first thing that we need to do here is we need to observe it. The variables are not separated and it is separable. So we need to separate the variables first so that we can now integrate both sides. So now here we have x dy plus 2y dx equals to 0. So now we need to obtain the integrating factor. So here, since we have the y at this side, so we use x to divide this particular side, then we're going to use that x to divide this other side too. And here, since we have the x at this other side, we need to remove this y from this particular side. So we're going to use 2y to divide this one. The same thing, we include that, we'll bring that 2y to this other side as well. So now here, since we have the y, we need to remove this x from here. And here since we have the x, we need to remove this 2y from the other side. So now the integrating factor is now 1 over 2xy. So that is 1 over x times 2y. That's the integrating factor. So now, after doing that, x will cancel x, 2y will cancel 2y from there. So this implies that the y over 2y is equals to the x over x. Okay, that's the y over 2y plus the x over x equals to 0. So mind you, this y cannot cancel this y and this x cannot cancel this x. It's impossible. So now we'll now integrate both sides. So integrating both sides, so I need to have integral the y over 2y plus integral the x over x equals to integral of 0. So now we can write this as we have integral 1 over 2y dy plus integral 1 over x dx equals to integral of 0. So now from here, this 1 over 2 is equals to, we can bring it outside. So here we have 1 over 2 here, integral of y 1 over y dy plus integral 1 over x dx equals to integral of 0. So now from here, so I need to have something like this. 1 over 2 times 1 over y dy will still give us something like this or something like this. So it's still the same thing. So now here we have at the down part we have y. Once we integrate 1 over y dy with respect to y, now we want to integrate 1 over x with respect to x. So now we need to check what we have at the denominator, this y. Since we are integrating with respect to y, so now when we differentiate y, it must give us the numerator, otherwise then we'll factor it. So here, integrating 1 over x with respect to x, so by the time we differentiate this x that we have at the denominator, it must give us the numerator, otherwise we factor it. So now from here we're going to have 1 over 2. So 1 over 2 is outside there. Here we have 1 over 2. Integrating 1 over y with respect to y, that will give us ln y, or we can say log y. So integrating 1 over x with respect to x, that will give us ln x. Now integrating 0, that will give us the constant c. So integrating 0 will give us the constant c. So that's the constant. So now from what we have here we have 1 over 2 ln y plus ln x equals to c. So here, since we have 1 over 2, we can make it linear by multiplying both sides with by 2. So we can use 2 to multiply both sides. So I need to have 2 times 1 over 2 ln y plus 2 ln x equals to 2c. So from what we have here, these 2 will cancel these 2. We have ln y plus 2 ln x equals to 2c. And from what we have here, from the law of logarithm, so we can take this one to the power, so that we can have ln y plus ln s squared equals to 2c. And since we have addition sign in between, so we can write it as ln of, that's s squared y, or we can write y s squared equals to 2c. So now here, since we have ln at this other side, we can introduce the ln to the other side as well, so that this one will cancel this. So we now have s squared y equals to 2c. So s squared y is equal to 2c, and we can make this one equation star. So this is the primitive. It is now from this primitive that we are going to obtain the particular solution. So that will take us back to the question at point 2, 1. So the first point given here, this one is x, then the other one is y. So that means we'll go to this particular equation star, the primitive. Wherever we see x, we'll substitute 2, and anywhere we see y, we'll put 1. So now, so let me clean this side. So from here, put x to be equal to 2 and y to be equal to 1 into equation star. So that is the primitive equation star. So and from equation star, we have s squared y equals to 2c. So now it simply means the value of this one, that's 2 in bracket raised power of 2. The value of y is 1 equals to 2c. So we want to obtain the value of c from here so that we can get the particular solution. So 2 raised power of 2, that's 2 times 2, that will give us 4 in bracket 1, 2c. So this one will give us 4 equals to 2c. So this implies that 2c is equal to 4. Then we are going to use 2 to divide both sides. So that 2 will cancel 2. 2 here 1, 2 here 2. Here we have c equals to 2. Now we'll now go to this particular place. We'll now go to the primitive. We'll go back to the primitive. So instead of writing s squared y equals to 2c, we'll now substitute the value of c to be equal to 2. So therefore, the required or the particular solution to the question given is, s squared y equals to, the value of c now is 2. So this implies that s squared y is equal to 4. So this implies that the required solution is equals to s squared y equals to 4. Kindly like this video, comment and follow for more. Thank you.